Hello, welcome back, Casibang's crew. We are on video number 2 in Unit 4, our biology unit. Today we are going to talk about neurotransmitters. So when we left off in our last video, we were talking about neurons and how the signal passes through the neuron. It starts as an electrical signal, and then when it gets to the end of its first neuron in that neuron or axon terminal bud, it turns into a chemical message. And this is the chemical message, are the neurotransmitters that we're going to talk about today. So a couple of objectives. One is the same from the last video. Identify basic processes of transmission of a signal between neurons. And then the new one, discuss the influence of drugs on neurotransmitters. So there are 7 neurotransmitters that you have to know. It sounds like a lot, but count yourself lucky. We have over 100 neurotransmitters in our body, and College Board's only requiring that you know 6 of them. Okay, so we are going to go through these 6. First thing I want you to know, again, neurotransmitters are chemical messengers. So there are 2 different types of chemical messengers here. There's excitatory. Look at my meme there. I'm so excited. Okay, so they are connecting neurons and they're causing them to fire. Okay, so it's just causing that message to keep going from neuron to neuron to neuron. And then there are inhibitory. Think inhibit, to stop. Okay, so inhibitory neurons prevent that next neuron from firing. So that message is traveling down the neuron, traveling down, and then it just stops, okay, if it's an inhibitory neurotransmitter. So on your video notes, you have a graphic organizer like this. So we're going to go through the neurotransmitters that you need to know. The first one is acetylcholine. Okay, and it is abbreviated this ACH, so make sure that you're aware of that abbreviation as well. So acetylcholine helps with our muscle action, okay, being able to move our muscles, learning, and memory. So when we're talking about malfunctions, we're talking about either your brain is producing too much of the neurotransmitter or it's producing too little of the neurotransmitter. So obviously things can be a little bit different depending on if there's too much or too little. So for example, Alzheimer's disease is associated with acetylcholine. So this is when there is too little acetylcholine happening in your brain. The acetylcholine producing neurons deteriorate in your brain. And that's why if you've ever known anyone that has Alzheimer's, that's why they have difficulty with their memory. Remember the excitatory and inhibitory, acetylcholine can be both. Okay, so just make sure that you're noting that on your chart there as well. The next one is dopamine. Dopamine helps to influence our movement, learning, attention, and emotion. Okay, too much dopamine is linked to schizophrenia. It's one of the mental illnesses that we're going to talk about toward the end of the year. And too little is associated with Parkinson's disease, okay? The tremors and the inability to really move very quickly, that's associated with Parkinson's disease. Serotonin. Serotonin is, let me go back. Dopamine is both inhibitory and excitatory, okay? It is both. Serotonin affects our mood, hunger, sleep, and arousal. An undersupply here, so too little serotonin is linked to depression. That's why we do have some very good antidepressant medication that helps to raise the serotonin level. And we'll talk about that when we finish this unit and talk about drugs. All right, norepinephrine is excitatory. Okay, excitatory. I can't remember if I said serotonin is inhibitory. Okay. Norepinephrine is excitatory, and this helps to control our alertness and our arousal state. So an undersupply here can lead to depression, okay? It can depress our mood. So it is affected in depression as well as in bipolar disorder. GABA, okay? GABA is a major inhibitory neurotransmitter. This helps to regulate our sleep and wake cycle. So an undersupply here could be linked to seizures, tremors, and insomnia. Okay, glutamate. Okay, glutamate is a major excitatory neurotransmitter, and it is involved in our memory. So too much glutamate can overstimulate our brain, which can lead to migraines, it can lead to seizures, and some other things. So glutamate is a major part of MSG, okay, monosodium glutamate, that you can find in food and a lot of Chinese takeout food. Okay, so that can lead to migraines and seizures. It can also lead to epilepsy. The one that I do not have on this chart that I do need you to write in is endorphins. Endorphins. P-H-R-I-N-S. Endorphins. Okay, endorphins are naturally occurring pain neurotransmitters. So if you've ever walked into your bedroom and you stubbed your toe and it hurts so bad for the first 30 seconds and then the pain starts to go away, it's because your body has released endorphins. Okay, so it has cut that pain signal for you. So endorphins are inhibitory. Okay, they are inhibitory. They are going to help us decrease that pain that we might be feeling. All right, so along with neurotransmitters, we are going to talk about another confusing pair. Okay, so mark it as a confusing pair, however you've been doing that. Agonists and antagonists. Okay, so these are both outside substances, not naturally made in your body. Okay, outside substances that interact with neurotransmitters at the receptor site on dendrites of the neuron. Okay, so both interact differently at the receptor site. For the most part, when we're talking about agonists and antagonists, we're talking about drugs, for the most part. Not everything, not every agonist is a drug, but if you think of it in terms of that. So these are not naturally occurring in your brain. Okay, these are other substances that we have somehow ingested that will affect our neurotransmitters. So we're going to kind of do agonists and antagonists. We're going to kind of use an analogy of a key. So if you think of keys that you have or that you've used, okay, so you have your house key, maybe you have a master key that opens up all of the locks in your house, and then you could have a fake key or just the wrong key. So when we're looking at agonists, we're talking about something that mimics the neurotransmitter. Okay, so this is something outside our body, but it mimics what the neurotransmitter does in our body. So it fits into the receptor site like a master key. It works just like the original key, but it's not exactly the same. Okay? And then antagonists block neurotransmitter activity. Okay, so they fit into the receptor site like a fake key, and it prevents the neurotransmitter from reaching that receptor site and doing its job. Okay, so the agonist mimics it, so acts like a neurotransmitter, and the antagonist blocks the neurotransmitter. So some examples: an agonist, morphine. Okay, if you've ever had surgery, if you've ever been in the hospital, if you've ever broken a bone, you may have been given morphine. Okay, so morphine mimics our natural endorphins. Okay, so think of the effects of morphine, any kind of anesthesia if you're having surgery. Okay, how does that make sense given the role of the endorphins? Okay, I just want you to think about that for a second. How does the agonist mimic, okay, the morphine is mimicking an endorphin? And then antagonist, Botox. Okay, we've heard of Botox to make ourselves look younger. We inject it into our face, into our wrinkles to make us look better. Okay, so Botox is a form of botulism. Ugh. Okay, botulism happens to block acetylcholine. Right, that neurotransmitter of acetylcholine. So again, think of the role of acetylcholine. How does it make sense that Botox would block its ability to do its job? All right, so I really love this graphic because I think it really is a great visual image on agonists and antagonists. So if you look at this first picture here, this is the neurotransmitter. So down here, this brown part down here is the receptor site, and the blue part up here is the neurotransmitter, and it fits perfectly, like a perfect puzzle piece. Okay, it fits perfectly. The agonist it mimics that neurotransmitter, but it's not exact, okay? So you see it fits, but it doesn't exactly fit perfectly here. And then our antagonist blocks the neurotransmitter. So here it's just kind of like a lid or a cap over that neurotransmitter. And now none of our blocks, the receptor site. So none of our neurotransmitters can now get in. All right, so that is it for neurotransmitters. We are going to do a little bit more with this in class tomorrow. Please remember, bring your questions. Bye-bye.